SQL, the InfoSphere BigInsights SQL for Hadoop, has gained power and speed in the BigInsights version 3 product. For the next few minutes, I want to show you how to get the best performance you can from Big SQL. Let's start by looking at the architecture and see how Big SQL fits into the BigInsights platform. The Big SQL architecture uses the latest relational database technology from IBM. The data remains on the DFS cluster with no RDBMS structure or restrictions on the layout and organization of the data. Big SQL statements are run by the Big SQL server on your cluster against data on your cluster. Applications connect on a specific node based on specific user configurations. SQL statements are routed through this node, which is called the Big SQL Management Node or the Coordinating Node. There can be one or many management nodes, but there is only one Big SQL Management Node. SQL statements are compiled and optimized to generate a parallel execution query plan. Then, a runtime engine distributes the parallel plan to worker nodes on the compute node and manipulates the consumption and return of the result set. The compute node is a node that can be a physical server or operating system. The worker nodes can contain the temporary tables, the runtime execution, the readers and writers, and the data nodes. The data node holds the data. When a worker node receives a query plan, it dispatches special processes that know how to read and write HDFS data natively. Big SQL uses native and Java open source based readers and writers that are able to ingest different file formats. The Big SQL engine pushes predicates down to these processes so that they can, in turn, apply selection closer to the data. These processes also transform input data into an appropriate format for consumption inside Big SQL. All of these nodes can be on one management node or each part of a separate management node. We recommend that you consider separating the Big SQL management node from the other Hadoop master nodes. This arrangement can allow the Big SQL management node to have enough resources to store intermediate data from the Big SQL data nodes. Big SQL accesses data on HDFS, but it creates and uses local database data. You can specify where you want Big SQL to store its temporary working data in the installation wizard. Select the Advanced button to access the information that you need. In the Installation wizard, in the Big SQL Data Directory field, specify multiple paths for the data to get better performance from your queries. These paths become the storage containers that are associated with the local database. The cluster status page in the web console has some useful settings that you might want to pay attention to if you are concerned with performance. For the best performance, you want to make sure to limit the amount of space that is used for logging, limit the logging that is done, and you want to limit the alerts that are generated. Click Manage Alerts to see a view of alerts that you've enabled or created. Inside the Manage Alerts page, you can view and modify the status of alerts and even create your own alerts. For the best performance, keep the alerts to a minimum. Click the Log Settings page. For the best performance, do not set the logging levels to debug or trace. These are only a few of the performance best practices. You can find the latest documentation and examples of Big SQL on this website. Thanks.